Imagine creating a device that could send messages through thin air without any wires. Today, we're going to demystify the process of building a simple radio frequency transmitter using just a transistor, capacitor, and coil. These components may sound complex, but they are actually quite basic and fundamental in the world of electronics. Radio frequency, often abbreviated as RF, is a type of electromagnetic wave used in communication. Think of your favorite radio station, your home Wi-Fi, or even your mobile phone. All these devices make use of radio frequency for wireless communication. Building an RF transmitter involves creating an oscillating circuit with these simple components. This circuit is the heart of the transmitter, generating the pulsating current that creates the radio wave carrying our signal. Don't worry if this sounds a bit technical right now. We'll break it down step by step, making it easy to understand. By the end of this video, you'll have a basic understanding of how a simple RF transmitter works. Think of the transistor, capacitor, and coil like the heart, lungs, and blood vessels of our RF transmitter. The transistor, acting as the heart of the circuit, controls the flow of current. Just as the heart beats to pump blood around the body, the transistor rapidly switches on and off, propelling the current through the circuit. Now, imagine the capacitor as the lungs of the circuit. Similar to how our lungs store and release air, the capacitor stores and releases electrical charge. It helps control the rhythm of the transistor's on-off cycles, just as our lungs control the rhythm of our heartbeat by regulating our breath. Finally, picture the coil as the blood vessels of our RF transmitter. It enables the current to flow smoothly through the circuit, much like blood vessels enable blood to flow throughout our body. The coil, or inductor, also plays a crucial role in creating the oscillating electric field that is necessary for the transmission of radio waves. Together, these components form a dynamic living system. They work in harmony, each playing a crucial role in the operation of the RF transmitter. The transistor's rapid switching, controlled by the capacitor's charge and discharge cycle, generates a pulsating current. This current races through the coil, creating an oscillating voltage that induces the radio wave carrying the signal. This process is constantly repeating, creating a rhythm that's as constant and vital as the beating of a heart. And the frequency of this rhythm, this on-off pattern, determines the radio frequency of the transmitted signal. The values of the capacitor, transistor, and coil, the heart, lungs, and blood vessels of our circuit, influence this frequency. Just like our body, these components work in harmony to create an oscillating circuit, which is the foundation of our RF transmitter. Now that we know the roles of our components, let's see them in action. The process begins with the capacitor charging up, storing that crucial electrical charge. As it fills, it eventually reaches a point where it triggers the transistor, our electrical switch, to turn on. With the transistor activated, current flows through it, creating a feedback loop that influences the capacitor's charge and discharge cycle. But it doesn't stop there. Due to the clever design of the circuit and the capacitor's natural discharge, the transistor eventually turns off. But like a well-choreographed dance, the cycle of charging, transistor activation, current flow, and deactivation repeats itself rapidly, creating a consistent on-off pattern. This pulsating rhythm isn't just for show, though. It's this very frequency of on and off that determines the radio frequency of the signal we're transmitting. The values of the capacitor and other components in the circuit play their part in fine-tuning this frequency. And there you have it, a simple RF transmitter in action. Building a simple RF transmitter might seem like a daunting task, but with a little knowledge and the right components, it's entirely achievable. We've unpacked how a transistor, a capacitor, and a resistor can come together to create a pulsating current and, in turn, generate radio waves. The transistor acts as a rapid switch, turning on and off, while the capacitor controls the timing of these cycles. The resistor assists by limiting current flow and stabilizing voltage levels. It's crucial to remember that this is a simplified explanation. The art of designing and creating effective RF transmitter circuits demands a solid grasp of electronics and radio frequency principles. But don't let this deter you. There's a whole world of resources out there to help you explore the fascinating field of radio frequency transmission. You might even take the leap and try building your own transmitter. Just remember, before you dive into any practical projects, it's important to be aware of the regulations in your area. Remember to check local regulations before attempting to build your own RF transmitter. Happy exploring, and until next time, keep questioning and keep learning.